Hi guys, my name is Emilio. I am from Avara. I am VP of DeFi at Avara, and I currently leading the efforts for building new innovative products for Avara, for Aave Labs, and for the Aave DAO. So today we are talking about the next iteration of the Aave protocol, which is the version 4. A lot of thought went into the design of Aave v4. We are talking a lot about this protocol these days. I have been saying that when we designed v3 and we released v3, at this point we started designing it more than 3 years ago. I was thinking that actually there would not be a new version of Aave. I was thinking that like the v3 version would have been the last version of the protocol, eventually iteratively building on top of that. And I was wrong, because then over the years, while we were analyzing how users were using the protocol, how the DAO was interacting with the protocol, the amount of work that the DAO required to interact with the protocol, we realized that there were a lot of margin for improvement. So the main goal of v4 is going to be increase capital efficiency compared to v3. The risk management. So when I'm saying improved risk management, I mean improving the way the governance actually manages the risk, and the way that users perceive the risk within the protocol. Reduce, again, the workload for the governance, so that there is, with the goal of minimizing governance, the need for governance within the protocol, and also definitely to increase the modularity and extensibility of the protocol. The Aave v3, the v3 version of the protocol is already quite modular and extensible, I would say. But we will take things one notch further with v4. So we don't have that much time, so I'm going, without further ado, I'm going straight to the new features. And the main thing I want to talk about, the first thing I want to talk about, is the new architecture of v4. So the main difference that is going to be between v3 and v4, the highest layer of abstraction in terms of architecture, is the way that liquidity is managed, and how it's going to be possible to build on top of Aave v4. So in the previous version here, we had like separate kind of monolithic protocols where the liquidity provisioning part and the borrowing part were merged together, one another. What we noticed, so this basically created the need for different iterations of the protocol, where it was required every time to migrate the liquidity from one place to another. And eventually, if you would create separate markets, for example, Aave at some point, Aave Labs released like the Aave Arc, that was a kind of a proof of concept for institutional adoption of DeFi. That would also be separated from the other markets. So what we kind of realized when we started thinking about how the new architecture of v4 should look is that actually the liquidity provisioning part pretty much never changed across like different iterations of the protocol between v1, v2, v3. And also in v3, we had added a new feature back in the days that we call portals. Portals initially was designed for facilitate cross-chain deployments of liquidity, so to be able to move liquidity across different chains. It was a bit ahead of time, I would say, because back in the days when we introduced it, probably the multi-chain world was not as developed as it is today. But actually that feature, and when we started thinking about how to use that feature of the v3, the portals feature, made it pretty clear that actually that feature could be extended further to make it like integral part of the architecture of the new protocol iteration. So from that feature of Aave v3 portals, we basically inherited like the creation of one single liquidity layer, which is completely abstracted by everything else that is built on top of the protocol. So compared to here, where you have liquidity provisioning and borrowing part all merged together in one single protocol instance, here you will have a set of smart contracts that are completely independent from borrowing or cross-chain designs, for example, and where the liquidity is going to be managed. And the liquidity layer is going to manage supply and withdrawals of liquidity. It's going to manage limits, so draw caps, supply caps. It's going to manage interest rates. And it's going to manage liquidity premiums. That is a feature that we will talk about immediately after. So the interesting thing is that this is going to be completely segregated, and the borrowing part is going to hook into the liquidity layer and is going to work in a completely separate, independent way. So the cool thing of this is that in the future, if there is going to be the need to build new features on the borrowing side of things, you can just swap out the borrow module for a new borrow module, or even having them working in parallel and plugging into the same liquidity layer, drawing liquidity and reducing or eliminating the need of migrating, for example, liquidity from one version of the protocol to another. So this is going to be the major architectural change. There are going to be other implications of this particular architecture, some of which will be unveiled when the protocol will be released. And I think it's going to be pretty interesting because the extensibility of this will basically help building on top of it a lot of unique features. Some of those Stan will talk after me regarding the visual proposal. So one thing I can anticipate is, for example, this unified liquidity layer is going to be also the base liquidity layer for an eventual Aave network that might come in the future, where this liquidity layer is integrated at a lower level of abstraction in the network, and where users can tap into it directly and seamlessly, and other protocols can build on top of that as well. From the new architectural design and from the unified liquidity layer, the major change, the first major change I want to mention is the introduction of what we call liquidity premiums. So one of the problems that we noticed with v3 was the inability to price liquidity accordingly and properly. What this means is that on Aave in general, which has a unified approach to liquidity, we don't segregate liquidity into the Aave design, but it's actually, there is, for example, one single big USDC pool or one big ETH liquidity pool. What happens is that whenever an asset, for example, wrapped STETH or wrapped BTC, gets collateral status, so you can borrow against it, it immediately accesses the whole liquidity available in the protocol without any pricing difference compared to assets that might already be in the protocol. So for example, on the Ethereum market, I would say that the safest collateral that you can use in the market is ETH, right? Because it's, we all know the property of ETH. It's trustless, it's permissionless, it's the base asset of the network where gas is used. It's very strong and very safe asset. It's super liquid on the market. So I would say that, for example, on Ethereum, we can consider ETH as the less risky asset within the protocol. And other assets built on top of that risk, because, for example, if we consider wrapped STETH, which in terms of pricing is basically ETH, with an additional risk that we need to consider due to smart contract, to the smart contract implementation of Lido. There is a slashing risk. There is a secondary market liquidity risk, although like the way Aave uses it that is quite mitigated. But it sounds pretty natural to me that probably users using wrapped ST ETH as collateral, they should not pay the same rate that ETH borrowers are paying. So if I'm supplying ETH and borrowing USDC, I'm paying one rate. If I'm using wrapped ST ETH, this brings a different risk profile, and this risk profile is not completely mapped into the protocol because I have no way in V3 to differentiate between the interest rate that I'm paying here with this asset as collateral and the interest rate that I'm paying here. So this is one major improvement that we were looking for to implement in Aave v4. And the way it's going to work is that compared to the v3 version where there is one single interest rate curve, assets will still have one interest rate curve, but that interest rate curve will refer to the base risk, let's say risk-free asset, that in the case of the Aave v4 ETH market could be ETH, for example. So the interest rate curve will refer to the interest that borrowers are going to use if they use ETH as collateral, and all the other assets will have a premium on top of the interest rates, and the premium will be decided depending on market conditions, on centralization dependencies, on smart contract risk, and so on and so forth. So we can imagine, for example, that if borrowers using ETH as collateral are paying USDC at 3%, probably wrapped ST ETH is going to be paying a 0.5% premium on top of that. So borrowers using wrapped ST ETH as collateral, they are going to pay 3.5. And maybe wrapped BTC can be considered a bit higher in terms of risk because there is some additional centralization risk in the wrapping process of BTC. So maybe we can consider 1% premium. So users borrowing using wrapped BTC as collateral, they will pay a further 1% rate on top of the base rate, the one of ETH. And maybe isolated assets, isolation mode is a property of v3 that will be retained in v4. Isolated assets that are usually longer tail risk assets will probably have further higher premium to compensate suppliers for the additional risk added to the protocol. So I personally think that this was one of the missing links in v3, and this will basically help suppliers getting more risk-adjusted returns, and borrower paying a fairer rate for the risk that they are, for the overall risk that they are bringing to the protocol. So this was the first feature. This is going to be integral part of the liquidity layer, and going to be implemented at the level of the liquidity layer. So next feature. Again, this is also going to be integrated at the liquidity layer, and it's going to involve the adoption of automated interest rates. Why automated interest rates? I have to say that currently interest rate models on Aave work fairly well. The only problem with those, like for those who are not familiar with how interest rates on a protocol like Aave work, this could be the curve of typical interest rate curve of asset on top of the Aave protocol, where the interest rate increases depending on the utilization rate of the asset. So the more demand there is, the more the interest rate increases. And this aims at leaving a certain percentage of the total value supplied to the pool available for user to basically be fairly certain to be able to withdraw pretty much at any time. So the idea here is that the interest rate starts from 0, reaches a point, increases fairly slowly with a certain slope until a certain utilization, and then spikes up to basically either incentivize more users to bring liquidity or borrowers to repay to bring back the liquidity to safe levels. So the problem with v3 is that like Aave is currently deployed on 13 different networks, and there are like 100 assets available Some of those are the same instance of the same asset across multiple networks. And whenever you need to adjust interest rate curves, probably you need to adjust across all the markets. And it's a lot of governance work and risk management work as well. So the goal here is to automate these strategies. We are going to use an approach that is kind of novel in the blockchain world. Usually, until now, protocols like Aave, they use like PID or variations of PID controllers, which can be quite, which they can sometimes be quite reactive to changing market conditions. These interest rates here can change either because there is, for example, variability in how users supply liquidity to the protocol, or because there are market-wide movements. So, for example, we have seen lately there has been a quite strong uptrend. Interest rates have gone up across DeFi. That's kind of market-driven. It's not necessarily related to how users are behaving on the protocol. Thanks to fuzzy interest rates, we'll be using fuzzy logic, which is a mechanism used very frequently in control theory to control environments and variables that are hard to model or very computational intensive to model through formal mathematics. We rather use rules that we call fuzzy rules to kind of model human-like reasoning here, where you decide basically on certain rules that might move this interest rate curve accordingly, depending on market conditions, depending on how users are using the reserves, so that they optimize capital efficiency for the protocol and they reduce or eliminate the need for governance to intervene and basically change manually this curve to adjust to match market conditions, basically. Next feature, smart accounts. So here we are starting to talk about features built on top of the protocol, on top of the liquidity layer. Smart account is going to be needed to solve some UX issues of the V3 version of the protocol. So in Aave V3, we have, for example, some certain modes like calling E mode, isolation mode I mentioned before. This mode allow users to activate certain features of the protocol, but they have the drawback that whenever you activate such feature, you can only use the wallet that you are using for that position. So if you need another position, like standard position, for example, you cannot do it with one single wallet. You need multiple wallets. So you need to move your collateral to another wallet. You need to fund with gas the other wallet, and so on and so forth. So smart accounts, first goal is to solve this particular UX issue. So it will be built on top with some smart wallet capabilities as well, and will give the possibility to users to interact with the protocol using a single EOA and instantiating multiple smart accounts that can actually manage different positions with different modes, and or even plain position without any particular mode activated. So another feature of smart accounts is going to be the use and the implementation of vaults. This is going to satisfy one need that was expressed many times on the Aave governance forum, for example, and even by institutional customers. So it happens pretty often that users might want to be able to borrow from Aave without supplying the collateral to a liquidity pool, because they don't want, for example, they don't care about earning interest and getting liquidity risk. They care more about just being able to borrow. So with Aave V3, this is not possible. So if you want to borrow, you are forced to supply your collateral to a liquidity pool. You will earn interest, but on some collaterals, this interest can be negligible. So you might want to forfeit that interest just to be able to borrow and have the additional security that you are not exposed to liquidity risk. So Vaults is going to enable that. And the way it's going to be implemented is that users using smart accounts will be able to keep their collateral into the smart account, locked into the smart account, and borrow from the protocol without supplying to the liquidity layer. Basically, this will enable to segregate assets, will enable to segregate liquidity risk, and the protocol will only be able to access, the protocol will automatically lock the assets into the smart account, so it will not be possible to move the assets outside of the smart account. And eventually, the protocol will only be able to access the assets in case of a liquidation event. So if you need to be liquidated, the protocol will access the assets and move the collateral to the liquidator, which will repay the debt for you. Another feature, we are moving to features that are implemented in the borrow module of Aave before. Another major problem that we have always had with all the versions of Aave is it's basically at the moment impossible to change some risk configurations, especially referring to the liquidation threshold, which you can also refer to as borrowing power. So whenever an asset gets a certain borrowing power on Aave v3, it's really, really hard to lower that borrowing power, because if you try to lower it, you are affecting all the users. So potentially, if you lower it to 0, you could liquidate everyone. So it's a process, it's a fairly intensive process. You need to change, whenever you want to lower the borrowing power, you need to change the borrowing power very slowly by a few percentage points to avoid affecting users. And it's very governance intensive because it needs to go through governance to not change the trust assumptions. So this is going to solve this problem, because with dynamic risk configurations, we will not have one single configuration for every asset, but we will have multiple configurations every time a new configuration is created. New users that will borrow the asset from that point onward will be hooked to the new configuration, and old users will remain on the old configuration. So you will have a situation where multiple users will have different configuration, and this will allow to segregate and reduce the risk further, because you can change much more frequently without changing the trust assumptions. This also means that risk managers can be offloaded risk management completely without changing the trust assumptions. So risk manager will be able to change risk configurations, or even automate that using AI or using other, for example, fuzzy logic, the same approach as the interest rates, without changing the trust assumptions, because you are not affecting existing users. So this is going to be very, very useful to further segregate risk and reduce governance workload. Stronger Go integration. For those who don't know it, Go is the native stablecoin of the Aave network. Is fundamentally integrated with Aave at the moment by disallowing under the hood like supply of Go, but rather minting on behalf. So with V4 and the liquidity layer, and Go generation will be natively supported, so no need to go through basically what is a trick to allow Go to be minted. Users will be able eventually to decide whether or not they want to receive the interest from other stablecoins in Go. So if I'm supplying USDC liquidity, I might be willing to receive interest rate in Go, and the governance can use this, for example, to optimize interest return to the users by, for example, reducing reserve factor in case users decide to receive Go interest. There will be soft liquidation, which is a mechanism already pioneered by Curve with their CRV-USD, with some crucial differences because of the difference and the different way the architecture of Aave works. And there will also be an emergency redemption mechanism similar to what Liquidity does today, but it's going to just be an emergency mechanism. It's not going to be like part of the core functioning of Go. It's only if Go sustains like prolonged the pegging event, then the emergency redemption mechanism will be triggered. There is going to be an improved liquidation engine here, like the Aave v3 liquidation engine has been working fairly well over the years with minimal upgrades compared to the v1 version. I think it's time to renew it a little bit, and this will be done by implementing variable close factor and liquidation bonus, so users will be liquidated up to 1 health factor, so basically enough to bring the position back to safety rather than 50%, up to 50% like it happens today. It's going to be to liquidate multiple positions at the same time, and it's going to be modular because multiple assets can have different liquidation strategies. Other goodies, there is a lot more. So there is a post on the Aave Governance Forum which highlights all the features we will be releasing when the time is ready, a tech paper as well, which highlights more in detail how these features will be implemented. But there are a lot of other features here that can be that will be implemented. Thinking of automated asset offboarding, where the mechanism to offboard an asset will be automated at the governance level. Treasury management, which is brings a lot of governance work today, where the governance might want to consolidate assets that come through the reserve factor in one or a couple of different assets, for example, ETH, USDC. Liquidity customizable liquidation strategies, governance action, gas efficiency, a lot of stuff. I really, really recommend to give a read to the Aave Governance Forum, and there is a post detailing all these features and how they will work. So in conclusion, V4 builds on the strong, I still believe that Aave v3 is quite strong protocol. It is the biggest, largest protocol by TVL in the space if we exclude restaking, and it's growing very nicely. So I do believe that it's going to be, V4 is going to bring quite a lot of improvements on top of that, and it's going to be key for the Aave DAO to maintain like the leadership in the space. So it's designed for retail DeFi users as well for institutions. So we are almost ready to go to ARFC, which is the step for official governance approval for the development of V4. And I really recommend joining the discussion on the Aave Governance Forum if you want to follow and learn more about it. That's pretty much it.
Thank you so much, Emilio.
Thanks,
Please give
guys.
it up for Emilio.
Hope you enjoyed it. Thanks.